Hi Michael, thank you for sharing a video of your gazebo project. As you may remember, I am Jeff and I taught design at the University of Bath. I also got a rough understanding of mechanics. I did teach a bit of mechanics when I was at Imperial. Obviously not in the same level as Joss, but I can give you some tips and pointers from my experience of applying elements of mechanics into design projects, and hopefully give you a few pointers. Now, you've used timber as your gazebo structure, and most gazebos you purchase from, say, DIY shops like Homebase or B&Q are very lightweight structures, and they're made from tubular steel with plastic inserts or brackets. I think the first thing you want to kind of consider is that the timber you're using has the same structural equivalency as a steel tube. Obviously, the steel tubes you see in gazebos are very thin, very small, very light, in comparison to the timber you'll be using. But to kind of assess that your design is comparable to that of a bought a gazebo, you might want to just do some basic calculations on the second moment of area, look at the stress going through the tubular steel frame and the timber, and get a sense that your design's almost compatible with that. Of course, your timber will be heavier, bigger, because obviously it's not going to be as strong or as stiff as tubular steel. Another case in point about stress is to think about stress concentrations, or the K factor. So when you drill through tubular steel or timber, you weaken it effectively, because you have stress concentration points. Now, you want to take that into consideration with the amount of material you have around your timber frames where you've placed your bolts. Another case in point, just looking at your video, is that your bolts seem to be way out from your timber. You really want to either use smaller bolts or try and cover them up a little bit. Also, when you look at nuts, what I can't quite see from the video is if you've used washers at all. Now, washers are very good at protecting the surface of the material, dissipating force, and making it very easy to assemble and disassemble. You might also want to consider using nylock nuts. So nylocs have a piece of material inside the thread to stop it from loosening with vibration. If you don't have nylock nuts, then you can use two nuts together just to kind of lock them up, just to make sure that nothing loosens in your structure. Talking about the structure itself, if I just scroll down, I've made a little picture here. So what you have is you've got your kind of cross brace section. So if I was to draw a picture, sorry, I'll just change the colour of that. You've got this kind of cross brace structure here, which is very good. You can look at that as a two-dimensional plane, and it's very stiff in this direction. My main concern is that the forces going through the structure vertically are fine, but where you need to consider forces from other directions, so lateral forces going in the horizontal planes. Now, when you look at your structure, it's got this cross section at the top. Then you've got your four legs going down, and it's covered by a tarpaulin. And you mentioned that you've got your cross brace here. Okay, so if I just make that a bit clearer for you, and you've got this cross bracing here like that. Okay, so it's a 3D diagram on isometric paper, and then you have this kind of like a little section at the top here, and when you look at the tarpaulin above, it creates a nice little point, and it drapes over the side. So you've created a doorway entrance here, but what I would also like you to consider is the fact that you could probably stiffen it by having cross braces between each of the legs. So just replicate that brace around the structure. so that it's incredibly stiff. It will also mean that there's not a lot of extra stress going through these points. Now, if you look at the diagram, the 2D diagram here, you've created a cross brace here, which is absolutely fine. But there's a lot of force and stress going through that, especially if you look at lateral forces going through it. What you can do is, instead of having this sort of design going into the beam, you could have perhaps your cross braces like this. So then you have your cross beams going like this in equal direction. So you can still have that beam going off into make the peak of the gazebo structure here. But this will just mean that it's far more stiff in the lateral directions, because these forces can come in at any direction. But also what you want to try and do here is that if you are able to have a square section at the top there, then it opens up the possibility of creating a peaked structure. So you could have something like this instead, which means that you've got a lot more area at the top to play around with, and you limit the risk of bumping your head on the structure itself. So again, that's sort of the mechanics side. But then when you think about the design side, well, obviously safety is a big factor. You've got this structure which is quite low, and you're able to bump your head. You've kind of mitigated that with a block of wood, which is fine. However, what you want to try and do is maximise the area inside the gazebo to prevent anyone from striking the structure. And also what you have to take consideration from a safety perspective is that your structure is much heavier than a typical gazebo you buy in, say, DIY shops. It's much heavier, and it runs a risk of injury if it was to collapse or fall. So you need to make sure it's properly stiff and safe. So definitely check all those joints, make sure they're really safe. You mentioned there's a bit of yaw in there. That's because you've got this kind of parallelogram effect going with some of the joints, and you want to really make sure you brace it up so it's nice and safe. So in any consideration with design, you want to make sure it's really safe, and that will be to benefit of yourself and anyone who uses your gazebo. Now, cost as well, you mentioned that the timber frames were about £2.75. I think you need to kind of just work out the total cost of material you've used, including the bolts, and then equate that to the overall piece part cost of your gazebo, and then compare it with one you would buy from a DIY store, for example. And that also includes the cost of the tarpaulin you've used. If it's something that's been lying around, you may want to consider it as a free or an open source. But fundamentally, what you want to do is show that your design is better or more cost effective than one you can buy in the shop. So again, thinking about design requirements, is the area or size is another factor you want to consider. Is it bigger than a standard gazebo? Is it bigger per cost, for example, of buying a traditional gazebo from a DIY store? And also you may want to take into consideration your time as well. How long does this take to construct? That takes into account the assembly cost. So assembly cost is based on labour rate, so how much cost you would pay yourself to build it, and the time. So obviously much of that's amortised into a product you would buy, but obviously if this is taking a day of your time to construct, you may want to think about the cost implications of that. Could you have been doing something else more productive? And what you want to do is justify your design against something you would buy from a shop. Fundamentally, it's a great DIY project, but that's some of the kind of design and mechanics attributes you need to consider throughout. So hopefully that's been useful for you, and good luck with all your studies and DIY projects in the future. Thank you very much.